damages. And after last class, I had to check it and do some investigation. I noticed that there was some leak in the wall, so which I had to call a plumber, which he had to fix today. So it really opened my eyes, opened, expanded my knowledge about knowing some things about walls when it gets to a certain level, when it's kind of murky or wet in a particular place.
Facility manager at the end of the courses. So today we are going to hear more and learn more through the interactive session of this class. So as I said, our module for today is electrical and power system maintenance. So in this module, you are going to learn why it is important to pay attention to your electrical facilities. You know, like I made mention in the introductory class, in the induction class, you might have installed all the gadgets
The network. Yeah, I can't hear anything.
I think it's the
I can't
network.
hear anything, please.
I think it's the network. And we're back, probably.
I can't hear anything. I don't know if it's only me there.
What is happening, Madam Barakat?
Seems it's network. I'm afraid of electric, that discuss about electric. Like, earlier shocked me, God. I don't get myself. I dare not play with lights. Only to fix bulb. I'm sweating. Good.
Okay, good evening, everyone. Apologies for the interruption. The facilitator is trying to get back on. I think he had some network interruption earlier, but he's trying to join back. Please just hold on. Or in the meantime, yes, we can continue with our takeaways from the last class on building fabric and structure maintenance. So I saw Mr. Adebola Abiodun hands up the other time. I'm sure he wanted to contribute to that session. So Mr. Adebola Abiodun, you can go ahead now. Thank you.
Good evening, ma. Good
Yeah,
evening,
good
class. Last week, spoke about the building fabric and maintenance. I learned a lot. So started from the foundation. I was exposed to different type of foundation, followed by the blinding, even the wall, that the bricks they use in building it. So after that, I learned about linted. I learned about roofing, different kind of roofing. That really opened my eye to different kind of roofing. Also, we learned about the ceiling, that is like the ceiling. So we spoke about suspended ceiling, POP, and some other stuff. We talk about the doors and the windows. So apart from that, we spoke about some technical issue in the building that cause like water dampness, which I am experiencing currently where I'm living. So I was made to know the cause of the dampness and also the way to address it. Hello.
Yes,
Hello?
we are with Abiodun. Yes, we are with you.
Well, thank you. I said that's what I've learned last week.
All right, thank you very much, Mr. Abiodun, for that. This is quite impressive. Well done.
Thank you, ma.
So, let's have Mr. Leo Anyete. Yes, I'm not sure I've heard Mr. Leo speak in this class before. So, Mr. Leo Anyete, please, let's have lessons from the last class. Thank you. Mr. Leo Anyete.
Yes. Hello, good evening, everyone.
Good evening, welcome.
Okay, my take from the last class was on the ways of the way we can clean the different types of floor, ranging from the terrazzo to the tiles, the wooden floor.
Leo, your audio isn't coming. Yes, I can hear you, but your audio, I don't know. I think there's some interruption from the background.
Oh, sorry. Okay, so I said my take from the last class was from the ways we can clean the different types of floor, ranging from the terrazzo floor, the tile, the wooden floor, and the rock as well, where facilitator made mention of that for the rock, you don't use water, you use more or to move out to suck out the dust and the sand. And then for terrazzo, you use the specified, for tiles, you use the specified lubricant. Uh, is it soap or something? The specified lubricant to clean the tiles. And if any hardened stain, you get to go down and maybe apply a scrub, a brush or something to take it out. Then for the terrazzo, hello?
All right. Thank you very much, Mr. Anete, for that contribution. The facilitator is not around. I would like to thank you very
All
much.
right, thank you. Thank you for your experience you have shared with us. Like I was saying before now, I said the need to pay attention to electrical power system is very, very crucial. So without proper electrical maintenance, without good electricity to your facility, your installation, your equipment installation is as good as installing nothing. So in this class, you will learn why it is important to pay attention to your electrical system, the various approach to managing this equipment, how to reduce cost, how to minimize risk, and how to also ensure that it's a safe working environment in your facility. So these are the housekeeping rules. So like I said, you need to pay attention to this training and eliminate possible interruption during the session. So there's need for you to ask questions. That will be done at the end of the class. So there's going to be a break time for a few minutes. We'll come back so that we'll round up the class on time. These are the course objectives. At the conclusion of the course, participants will be able to understand the underlisted points, the basis of electrical energy and power, be able to carry out load analysis to determine whether you are overrating your equipment or you are underrating your equipment. So you know sources of power. Why do you know at the end of this class? We have two types of parts, compartment in general, the electrical part and the mechanical part. Then we look into the importance of equipment maintenance, transformer and each function. Why do you need transformer in your building? Why don't you stick to the public one? You know about that at the end of this class. And also the importance of earthing. So you know what is called earthing and why is it important in your installation. So in this same course, we are going to be introduced into definitions like power generation as a network of interrelated equipment, sources of power, type of power, direct and alternative power, or the one we call DC current and AC current. So you have what we call load, conductors, electrical installation and protective devices and their usefulness. Why do you need to protect your equipment? Why do you need to protect your installation? At the end of this class, you will know why you need to do that. All right, let's get to business. You know, power system, like I said, is you cannot underestimate it in your facility. If they want to rate a facility manager, most especially in this country, if you have a fluctuating power or there is continuous outage in your facility, everybody will be aware. Escalation will be flying here and there. So you need to pay attention to your power system. What is power system? Interconnection of electrical components for the supply and transfer of electrical power. So power system does not exist alone. They don't exist in isolation. It's a combination of equipment like generating station, the conductor, the changeover switch, the distribution board, the ATS panel, automatic transfer panel. All of these equipment makes up what we call power system. They are interconnected together. That's why a generator is stationed outside your building or very far off your building, and the result is fed in the building. So equipment are responsible, or items are responsible for the generation of this electricity, transmission, and distribution. So if any one of these is missing, your power system is not complete. So the process of transforming energy into electrical form, that's mechanical energy into electrical form, is what we call electricity or power system. This subsystem produces electricity. So, like I said, as you can see, we have what we call power station here. This is a typical example of power system arrangement. We have the power station, which is the generating station. In Nigeria, most of us are familiar with Kainji Dam. There are other power generating stations in the country. For example, Niger State has about 4 or thereabout power system generating station. Let's narrow it down to your facility. This is like that your generator at the corner of your building. So electricity power is produced in this station, this power station, is being transmitted from where it is generated through conductors, like as you are seeing here, to a transformer. Why do we need a transformer? Is to modify the power that has been generated into a usable form. For example, a 60 MVA power generating station needs a transformer to step it up so that it can be transmitted over a distance of, over a long distance. So in the process of transmitting, you need another transformer that will step it down to the value that is acceptable by the end users. Like in production, we said a producer have not produced anything until the end user, the consumers, are satisfied. If you are producing and nobody is satisfied with what you are producing, you are not producing. The same thing with electricity. If you are generating and at a very high voltage, nobody will want to use such voltage in their facility. It's either it sets the facility on fire or start damaging things in the facility. So that's why you need a transformer to bring it down to a level that can be tolerated by the end user, because they are the ones to give feedback of what you are producing. If at the end of the day, your supply is damaging my fridge, is damaging my air conditioning, damaging my lift, so I will search for alternative. That means you are producing at a loss. Nobody is using your electricity. So they are transmitted over a long distance of time to the various users. As you can see, we have the commercial users and the residential users. So this is where most of us fall in. And in this generation station, voltage is transmitted, power is not transmitted. So you transmit, that's why you have 33 kV, like the tower you are seeing here is rated in 330 kV, 132 kV, 33 kV, and 11 kV, as the case may be, depending on what you want to achieve. But at the end of it all, you are looking at 400 to 450 for three-phase, or 200 to 240 for single-phase users, which is the residential users. Electric power is a product of current and voltage. What makes up electric power is the current and the voltage. Resistance is also there. So if the resistance is too much, that's when you have low voltage. If opposition, current is coming, voltage is coming, there is a strong opposition, which is the resistance, it will start giving you low voltage. The reason why you have low voltage in most cases is because of resistance, deposit of carbon or debt that is at the terminal or the connection point. So that is why you need to clean that terminal point at on a regular basis, so that there will be free flow of electricity to your apartment or to wherever it is needed. So we have two types of electricity. We have the direct current, which is usually called the DC power. And this DC power provides a constant current or voltage. They are generated through battery or rectifier. Equipment that use most type of this current is the computer and the digital equipment. So on the other hand, the alternative current, which is oscillating from one side to another, in electrical engineering is called sinusoidal. They move in sinusoidal form. They are transmitted, the power are transmitted over a long distance, like the one I show you from here. So this is alternative current, is generated and transmitted over a long distance of places. They are generated through an alternator, like your generator at home. We have the mechanical power where you set the engine in motion. As it's rotating, as it's working, electricity is produced through an alternator. Maybe most of us have heard that, oh, the alternator is bad. The alternator is not producing well. So electricity is generated through alternator. In alternator, we have the stator and the rotor. Two components, two major components are involved, the rotor and the stator. The rotor moves around the stator for electricity to be generated. I'm just giving you this introduction so that you understand how electricity is generated. So equipment that make use of this alternating current are the refrigerator, air conditioners, and pumps. These are the equipment that makes use of alternating current. So we have a type of power system where the power is part of the system. The power source is part of the system. For example, your phone, your computer, your laptop, the power system is embedded in your phone, like the battery. Battery is a source of power. While some equipment, their power supply is external, like your bulb, your fan, they get their source externally. While some get their source internally, like your battery in your laptop, your PABS, and other equipment. We have what we call load. What is load? Load is anything that draws current, that requires current to be driven. For example, your motor is a load. Your fan is a load. Your AC is a load. Your computer in your facility is a load. Anything that requires current for it to be driven, it is called load. So that's why it is very important for you to know how much load you have in your apartment or in your facility, so that you are not overstressing your source of power, like your generator. If you don't know the exact load that you have in your equipment, in your facility, you may go for any kind of generator. And when you power this generator, the generator will start humming, going up and down because it's overstressed with too much load. But if you know the exact load that you are meant to, you have in your facility, you go for the right sizing of your generator. So you don't need, it's not a rocket science. So just put them together. You have some number of, but that's what we call load analysis. You determine the type of load. You have three-phase load, you have single-phase load. So pull them together, and it will help you to also distribute your power supply so that you have a balanced load on your generator or your source of power. If your load is imbalanced, if a phase is overloaded, it will affect your alternator, it will affect your transformer because the power system are stressed beyond what they can withstand. So it is good you balance your loading with respect to your generator or your transformer. Load ranges from industrial equipment to household appliances. Like I said, the lift, the three-phase load are for industrial, while the single-phase load are mostly for domestic household use. Load are expected to have a certain number of frequency and phases. Like the frequency that we use in Nigeria is between 49 and 52. Anything outside this range is regarded as out of phase. So when your frequency is out of phase, you'll be producing at a higher cost. Your cost of energy will go up. So it is good you maintain this standard between 49 and 52. So any appliance must have a specific wattage. What is wattage? Power range, a range of power. That is your electric iron, you say 1,200 watts. That's the power of that electric iron. Your AC, you have 2 horsepower AC. The 2 horsepower is the power of that AC. You have 1.5 horsepower. The same thing with lift. You say so number of kilograms and thereabouts. So every equipment has their specific wattage. So this will help you also further determine the amount of load that you have in your equipment. Power quality must be considered. Like I said, if you are producing electricity and the power is not clean, nobody will be able to use it. If there is high voltage in your home, I don't think you'll be bold enough to go and switch up your television that you bought like 500 or 1 million plus. So it will damage it. So ensure that the voltage or the power that you are bringing into the facility is good enough to power your appliances and also save you cost. If the power is not clean, the cost of running your facility will be high. So that is why you are here, to pay attention to the power that you are generating, the size of generator that you are using, and the frequency that is coming out of this from this generator or your transformer. The same thing with voltage value. Our voltage value here is 200 to 240, while the three-phase voltage value is 400 to 450. Anything outside this is out of range. Don't use it. You can tolerate plus or minus 5%, not all the time. Ensure that these things are within industry standard. We have, as I told you from the beginning, when you are generating, you require a conductor or a cable to transmit this power to where it is needed. Such thing is called cable. Some of you are familiar with armored cable. Some of you are familiar with 2.5 mm for socket and so on. This is part of the power system we talked about. It's a network it's a connection of equipment put together to deliver the required power value. We have the protective device. Why do you need to protect your equipment. You protect your equipment so that you will not be running at a loss. If there is a surge in your installation or your facility, this protective device help to open the circuit so that the surge will not continue. Once it tolerates it and see that it can no longer, it will open like your circuit breaker, your fuse, it will blow off. So if whether you are there or you are not there, your equipment and your house is protected. The circuit breaker will open. Most of us have experienced this in our facilities. They will tell you there is no supply in so place. You go and check to see that the breaker is open. Mind you, before you switch on that breaker back, you have to ensure that the problem is resolved, is traced and resolved. If it's not resolved, don't put up that breaker again. Until that problem is resolved, that's when you can put up the breaker. So that's the essence of protection in your facility. It safeguards the personnel and the equipment and the investor's money. So if your installation is not well protected, when you leave this class, go around and check, do a load audit or a power audit and see what is missing and recommend to your management that this is what we need to put in place, because people money, stakeholders money is involved. So that's the essence of this class. We have power electronics. They convert rectification, that's AC to DC. Like the battery I talked about in your computer, what is coming in is AC power, that's alternative power. So this battery, there's a component that helps to convert this AC into DC so that your computer can receive 100% power, that's efficiency, no distortion. The battery that is inside your computer is not alternating. It gives a direct current, almost 100% clean power. So something is responsible. That's what we call a rectifier. It converts AC to DC or DC to AC. They are semiconductor devices. They switch it quantity of powers ranging from few hundreds watts to several hundreds of units. So we have residential power system. Like I told you, it's between 200 and 240 volts. They run through cable. So we have the commercial power system as well. They are used in high-rise building or malls, where you have three-phase motor, three-phase industrial machine. So what you need here is between 400 and 415. So those are the type of power that we have. Home and office electrical installation. We have the radar and the ring. So in most cases, we use distribution board instead of the normal fuse that we are used to in the old days. But now we make use of distribution board. Like I said, distribution board has the various sizes of circuit breaker. We have the 10 amps, we have the 50 amps, we have the 20 amps, 32 amps, 63 amps in an enclosed case. That's what we call the distribution board, where power is taken from a dB to where it is feeding. So, for example, when you see a 20 amps breaker, you know that should be for AC, or 50 amps, that should be for AC. So if you see a 32 amps breaker, you know that should be for a pump or whatever. So it helps you to identify equipment easily. If there is a fault in that equipment, it will trip the breaker that is feeding it instead of tripping the whole unit. So the breaker is identified. You have to trace what is responsible. It could be a compressor that is bad, that is tripping the breaker because the voltage is abnormal now for the compressor. There's a feedback. And mind you, whenever there is a fault from somewhere, it tends to go back to the source. That's why you see a breaker will trip. Instead of damaging that equipment that is protected, it will open the breaker and your equipment is safe. Ensure that your breakers are sensitive enough. Anyone that is not sensitive, you remove it and replace it with a new one. You don't repair breakers, you replace. And unlike the fuse that your technician will just go and get a wire, twist it together, and put it and tell you, okay, it is working. It's working, but it's not protecting anything. You may feel the technician knows what he's doing. Actually doesn't know what he's doing. Because of that, a whole building can be set ablaze because the wire that he used either is overrated or is too thick for it to open when there is a fault. But a circuit breaker will trip whether you are there or not. Like I mentioned here, do not repair a circuit breaker, replace it outrightly. All right, we have home and office electrical installation. We have the ring type of electrical installation. The ring type installation is where you loop wire from one point to another, one point to another. So most people tend to go with this arrangement because of the initial cost involved in installation. Initial cost of ring is very cheap, but the damage that is awaiting you is far, far above the cost you feel you are saving at the initial stage. So most people do this. I've had experiences in most of the facilities I've managed in the past. So they will tell you their parlor is heating up because there is looping within the parlor. Developers, they just want to build and go away. But the facility manager and the end users suffer most when they compromise standard. So I encourage everybody, I encourage people to take the pain to go for the radar type of installation where electricity or the power is evenly distributed. You take from your DB to your AC, from your DB to your electric cooker in the kitchen, your DB to your water heater in the bedroom, instead of looping or DB to a particular socket. So it is good you save money, but in the long run, you are not actually saving. The cost of maintaining a ring type of installation is high. For example, if there is a short circuit along the line and the panel is already completed, you have to break the ties, remove the ties. In the process of removing the ties, you may not have to see the exact tie in the market because ties changes every 6 months or thereabouts. So you are going to replace the entire ties and also remove the damaged cable and maybe other things that have been damaged because of the looping that was poorly carried out. So take home from here is when you are involved in project design or project management or building construction, stick to the radar type of installation where distribution is done from the distribution board. And the initial cost might be high, but on the long run, you are saving for your clients. All right. When you are given a project to supervise as a facility manager, you cannot say you are not a project manager. You are also a project manager, whether in depth or not. So you are expected to supervise a project. So these are the things you are going to be seeing, the drawing, not as you may see physically, but it's good you familiarize yourself with these symbols so that when you are called to interpret a drawing or electrical drawing, for example, you're able to identify, oh, this is where the fan should be, this is where the socket should be, this is fluorescent, or this is a bulb, so you know how they look like. That's the essence of this. So in the next slide, you will see the symbols and their names. So you need to ensure you are familiar with all of this for you to be a better facility manager. Design consideration: when you are employed for a project, these are the things you need to look out for. Type of supply and earthing arrangement. Like I told you, we have different type of supply, two types of supply, for example, the three-phase supply and the single-phase supply. Three-phase means three lines and three wires and neutral, making it four. Single-phase means one neutral and one live. That's single-phase. So when most people, when they call them, oh, they will tell you, you need a 60 kVA in this apartment. Who told you you need 60 kVA? What type of load are you going to be powering? So it's also a factor. If you don't need three-phase most of the time, you go for a single-phase generator. That's a generator that's for single-phase. If it's lighting point and just electric iron and coal, you don't need three-phase. For three-phase, we spend higher in procuring them and spend higher in maintaining it. We go for single-phase. So these are design consideration. The temperature involved, like the generator you recommend in Lagos here will be different from the one you recommend in Maiduguri. Maiduguri is very hot. Lagos is cold and full of moisture. So you may need a soundproof generator in Lagos to prevent salty water getting into the generator and damaging equipment. But in the north, you may not need the soundproof because their place is very hot. You even need to open the generator so that there will be cross ventilation, free flow of air into the generator. Possible presence of moisture, I explained this. Possible fire, possibility of fire. Is it close to a gas station? Is it close to a filling station? You check, put all this into consideration. If there is, you need to devise a means to ensure that they are protected against fire. Provision for future modification and rewiring. For example, if they ask you for 3-bedroom flats and a BQ or whatever, you may not need to recommend the exact generator size because of future do plus or minus 5 expansion and make recommendation to your client. So the probability of future extension, probable operating and mechanical maintenance cost is a factor that needs to be considered. For example, when you go to Canada or you go to Dubai, you see a very flashing light suspended up there, and you want to replicate the same thing here in Nigeria. Knowing fully well that over there's maintenance plan. Here, we don't have maintenance plan. We don't have it as our culture. So you install it, yeah, the developer is happy, install it. When you want to maintain, you have to go and rent a crane just to replace a bulb. So because you did not put maintenance cost and bringing in crane or scaffold, you may need to break some walls so that the crane can move in. So that's too much. So you consider operating maintenance cost. So if to replace a bulb of 700 or 7,000, you are bringing in equipment to replace that bulb for over 500,000. Does that make sense? It doesn't make sense. So you have to consider all of this. Relative cost advantage. So what are the alternative costs? If I don't want to replace put LED, is it possible I put other things? So you check what possible alternative do I have to be able to remain in the market or in the industry and not overcharging your clients. So those are the things you need to know, design considerations. So electrical maintenance. So we've talked about this, the conductors and the other potential electrical conductor. Potential electrical conductor means metals that are used in the olden days. Most houses still have metals as galvanized pipe in their bedroom. So ensure that they are properly earthed if you are still having such in your facility. So never you assume that a conductor is dead. So these are protection that you need to put in place while managing your facility. Can you still hear me, please?
We can't hear you, sir. Go ahead, sir. We can hear you now.
All right.
We can hear you now.
All right. Like I was saying, it is good you carry out testing in your facility. The advantage of doing that is enormous, and without proper testing, you'll be running helter-skelter. You feel you are working, whereas you are not working. You just be a workaholic. You are putting in more effort and no result. But when you are familiar with what is happening in your facility, like the testing you are carrying, you are documenting it, it will give you a pattern. And you know, even when you are not there, your technicians cannot bamboozle you because you are very close to your facility. So what it helps you to do is to have a pattern and to have first-hand information. For example, they will tell you the generator is due for service, whereas it's not due for service. The generator is fluctuating up and down. You check, oh, we just did the servicing of this generator. We did flushing of the radiator. We did this, we did that. We serviced the injector. What would have been responsible? Maybe the diesel you just supply is what the problem is. You didn't carry out the test that you were supposed to carry out. We have different kind of tests on the diesel. If you do not observe those procedures, it will land you in trouble. Could be the quality of diesel that is supplied that is giving you trouble. When you carry out it, you record it down. You take record of it and you pass it. When you're handing over, you pass it to the next person. So the appropriate cycle based on an assessment of the risk to alternate between. So it is good to carry out your testing. We have common electrical problem in the building. Common electrical problem. This is common to all facility. You have flickering of lights, maybe blinking. You have your bulb is burning out easily. Phase reversal, phase loss, tripping circuit breaker. Like I told you, your circuit breaker could be a bad compressor, could be a loose connection, as the case may be. So what you need to do is this. When you have this in your facility, it causes fault. The light is flickering. What is the cause of this fault? The solution is here as well. So these are the things you need to check out for. So ensure you master these points. These are problems we often face in our facility. Consumption monitoring. Why do you need to monitor your consumption? Like most people, whatever NEPA brings for them or their DISCO bring for them is what they present to their management. No, it's not always right. Ensure you know what you are consuming. If you are employed as a facility manager, they employ you to bring down, to optimize costs. You may not necessarily reduce costs. It's to optimize costs. So one of the responsibility before is to bring down the cost of operation. And I tell people, where you can easily bring down cost of operation is through energy. That is the power consumption. Maybe some people, they are leaving the office, the AC is still working. They are leaving their office, their dispenser is still working, it's still on. They are leaving the office, they leave their socket on. You know, sockets, we have like an indicator light there, is showing red. It's there permanently on. It's energy, it's consuming energy. Whether you like it, no matter how small it is, whatever way you see light, energy is supplied to that place. It's part of your monthly bill. What you need to do is to go around and switch off things that are not meant to be on, So you switch them off. You take, when you came, what were we consuming? What were we paying? You notice that maybe you are paying 10 naira. But because you're able to pay attention to details and you're able to eliminate this excess in wastage, then your next bill is coming to maybe 9 naira 80 kobo. You are able to save 2 kobo. So you continue like that. So you are monitoring your consumption pattern. So that's the thing you are going to present to your management. When I came, we were at this level of consumption. Now, in the last 3 months, this is what we have consumed. You show them cost reduction. That's part of your responsibility. So energy consumption monitoring cannot be underestimated. That's where a facility manager will shine. If you are detailed enough, you can bring from a reduction of about 25% or 20%, as the case may be. So these are we are not going to manufacture. They say we need you to generate money. We are not going to, you are not a production man. What they are telling you is to pay attention to details. Removal of excesses. If you need to install a motion sensor, if you need to install VRF, anything that can bring down cost, go ahead and do it. It's not by force, by presenting it to the manager. You will have to justify why you need them. All right? So monitoring of your consumption is very, very important. So we have maximum demand meter. These are, and the check meter. The maximum demand measure the total amount of energy in your building, while the check meter is used for individual apartment. Someone may say, I'm not around, I switch off my check meter. It will not read anything until he comes back. But the maximum demand will catch up every supply to that facility, and it will be deducted and shared to common area as well. So check meter helps to eliminate problem in an estate where you have multiple tenants. So just like your recharge card in your phone, if you don't use it, it stays there. If you use it, you pay for it. The same thing with check meter on the maximum demand. We have extra low voltage. I made mention of DC supply voltage. So DC is what we use for extra low voltage. So every facility make use of this. Your CCTV camera, your card readers, your access control, PABS, fire alarm system, they make use of extra low voltage. That's why, and they cannot tolerate alternative current, the AC, raw power, the one we call raw power in our building. That's why your battery bank needs to be maintained. That's where they get their power from. Clean power, 100% clean. If distorted, if there is a distortion along the supply line to this equipment, you'll be fixing either replacing them every now and then. And one of the reasons why you are there is to ensure that we bring down cost. If what you are doing is to replace and replace and replace without paying attention to what supply you are using, it means you have no business in that facility. Ensure your battery bank is okay. When you need to service them, you service them. When you need to change terminals, you change. When you need to grease them, you grease them. So because this CCTV cannot go off for any reason. The same thing with a baggage scanner. It cannot go off for any reason. So this life of every building lies in the hands of a facility manager. So ensure these things are functional. The sources of power to this equipment are okay. We have the transformer. Like I say, a transformer is not a generator. It's just a means of modifying supply. So it does not generate anything. It helps to step a certain value of voltage from a lower to a higher, from a higher to a acceptable one. So that's the functions of a transformer in electrical power system. Transformer is not a generator. It's only it's modification of voltage or power from one level to another, and it's also bring steps up, and also step down. Depends on what you want to get. We have the distribution transformer too. The first one is a power transformer from the generating station. Those transformers that are closer to your generator, they are called power transformer. We have the distribution transformer, where power is being distributed along this transformer. They can expect to transmit 33 kV or 132 kV in the transformer that we are using in our street. So what we have on our street is the distribution transformer, 11 kV, 415, as the case may be. So this is a dry set transformer. It does not require any form of oiling or water. It's problem free. What it needs is cross ventilation. So far as heat. Heat is air that is eliminating or expelling the heat that is being produced. When you go to most of these more mining station, these are the transformers that you see, because they are less of maintenance. So we have weekly maintenance of transformer. These are what you checked when you carry out weekly maintenance. We have monthly maintenance. These are what you look out for. We have the biannual maintenance. Ensure all of these are adhered to, so that you feel you are saving money. I don't need to maintain my transformer. You feel you are saving money. When the transformer breaks down, you spend times 10 of what you are supposed to use as maintenance cost. Ensure you pay attention to all what you are being taught now. So I want you to take like 5 minutes break. When you come back, we'll be looking at the concluding part of this module, like generator and the LT system. 5 minutes break from now, we will come back. Thank you. Are we together?
Yes, sir. Thank you, sir.
All right, 5 minutes time, we'll be back. So let's say
Thank you.
6:16 will be back. Thank you. Welcome back from the break. Are we together?
Yes, sir. We are together, sir.
Okay, welcome back. Thanks for keeping to time. Yeah, generator. One way or the other, I have made mention of generator. I've dwelled on generator, but I want to go into it proper so that most of us will know what a generator is. It's a machine that converts mechanical energy to electrical energy. It's a machine that converts mechanical energy into electrical energy. Like the generator you have in your apartment, and like I told you, it has two compartments, the mechanical part and the electrical part. The mechanical part has the injector, the oil sump, the piston, and co. While the electrical part has the alternator, which comprises of the rotor, the stator, the diode, the rotating diode, and exciter. So the difference between a generator and a motor is that a generator gives out electricity to external circuit or external device, while a motor converts electrical energy to mechanical. What that one means, it receives like your fan or your pumping machine, they are all motors. They receive electrical energy for them to be able to work. They don't generate their own electricity, but a generator generates and sends to other appliances for their use. So we have the commercial level generator and the domestic or industrial level generator, like the ones we are used to, like the 1000 kVA, like the 60 kVA, like the 2000 kVA. These are types of generator that we are familiar with. So alternating current generator also, like I told you, they are used to drive high level equipment, like your lift, like your chiller, your central ACs in the shopping mall. These are type of generator that we have. We have the single phase generator, like the one you have at home. Like I told you, when you are carrying out your load analysis, you have to know the type of load that you have in your building so that you will not go and recommend a 3-phase instead of a single phase, or vice versa. You recommend a single phase instead of a 3-phase. You have to know the type of load that you have in your facility. This is what makes you different from every other maintenance person. As a facility person, you should go to know the type of load that you have in your facility so that the cost or your function can be met. When you are selecting a generator, like I said, you know every equipment has their power rating, rating on them, power rating. That's what we call wattage. So you have to know the various wattage of your equipment, like your photocopy machine. How much power does it need? Like your fridge or your dispenser, how much power? Like your AC, what's their power? What's their power rating? If you know the power rating, you know the size of generator and the tolerance you'll be able to create for them. So there are procedures for installation. Engage competent technician or authorized service dealer for installation. For example, you engage Meccano, you engage Dubaili, you engage GMG, engage Matrat or Cummins to carry out your installation. You have to comply with industry standards on the SOP, as what we call as a standard operating procedure. So when you need to use the exact size of a cable to install your generator, but don't say you don't have money, you go and use a lower rating. Because if you do that, sooner or later your cable will melt. The money you don't want to spend, you go and be spending it because heat passes through your cable. If the heat is too much, the cable will melt. The insulation will be broken down, and there will be a short circuit. If not if care is not taken, it will damage your generator. When three lines are bridged together, it will affect your alternator. You end up losing everything. Whereas we wanted to save money by compromising standard. Ensure you practice according to industry standard, SOP. All right, these are what you carry out when you want to install generator, buy your generator. So these are the safety precautions you carry out when installing your generator. Make sure you go through your manual. Like I was saying, the electrical part of the generator is this. This is the alternator itself. This is the alternator. This is how it looks like. This is the stator, and this is the rotor. Are you not seeing it? This is
Yes,
the
sir.
stator. This is the stator. It does not move. That's why it's called stator. This is the rotor. This one moves around this alternator. This one moves around this one in opposite direction. As they are moving, try to catch up with each other, whereas they are not going to, it's not achievable. That's how electricity is produced. They go in opposite direction. Such principle is called Faraday's law of electromagnetic induction. That's what produces electricity. This is where electricity is produced in your generator. The mechanical part set it on motion. This thing keep rolling. You have the flywheel attached to the mechanical part. Keep rolling as long as there is fuel in the mechanical part driving the engine. This stator and rotor will be moving in opposite direction. Just like the natural wind. When you see a turbine, that looks like a helicopter. If you are moving along the city, you see something that looks like a propeller, a fan blowing. That is natural source of electricity. As wind is blowing, that turbine is moving. The same thing with this rotor. As long as there is fuel, this thing is moving, electricity is produced. As long as that thing is rotating, that looks like a helicopter on the street, electricity is produced. What produces electricity is rotation of coils. Wire runs into this thing and into this thing. They are trying to catch up with each other in opposite direction. That's what produces electricity. So stator contains a set of electrical conductors, one in the coils that is over an iron core, while a rotor produces a rotating magnetic field. So that's the principle of electricity generation, whether big generator, small generator, the turbine, the gas turbine, anything you can do, as long as there is movement of coils in opposite direction, movement of wire run in the coil, there will be electricity. So fuel system is also part of a generator. Without the fuel, the generator cannot work. So it's a source that drives the generator. We have the fuel pump. We have the pipe that ventilates the fuel tank. So in your fuel tank, you see a pipe that is open. That's where fresh air comes in. If there is no fresh air and hot fuel is coming, we have what called return the hose from your generator, because the whole fuel is not consumed as they are going in. The injector only take a portion of the fuel or some quantity of the fuel and convert it into do the combustion there. The rest are fed back to the tank. If there is no cross ventilation, the tank will heat up and the tank will explode. So that's why you create that opening at the top so that fresh air is coming. The hot air is escaping, fresh air is coming in. So that's what we call it's a closed loop system. We have the fuel pump. the fuel injector, the water separator. The water separator, if you're able to make sure your water separator is clean and is filtering well, your generator will last, the injector will not be corroded, the tip of the injector will not be blocked, the right fuel, the right quality of fuel will be sprayed into your injector, and your generator will last longer. But if the fuel is not well maintained, there's no water separator, it's just plug and play. Before you know, you start servicing your injector, dismantling, you start losing and coupling. So it's not good for any facility. Ensure simple water separator filter is replaced at every interval so that you can have a clean fuel into your generating system. We have the cooling system as well, the exhaust system, the battery. The battery is very crucial in your generator. A battery can sack you from your work if proper attention is not paid, because I've seen scenario where the facility assume that, oh, the battery is fine, don't need to check. The technician, if you don't push them, you are not the one doing it. You have to push your technician and ensure that they bring report to you every day. Battery is checked daily. So it could be that the terminal is not where it's not firm, and there's a board meeting ready to kick off, and they want to go and start this generator. The process of starting the battery fail. What do you think they will do to you? They can't clap for you. They can't say oh, that means you don't know what you're doing. So ensure all these things are taken care of and documented. If you need to change a battery, don't compromise. Don't say, oh, we can manage it. Battery can fail you at any time. So if you need to change it so that you can keep your job. So these are what you do daily. The generator, you do 250 to 200 hours as well as maintenance. Most people know that generator is serviced. The lubrication service is done between 200 and 250. And these are what you do when such service is carried out. This is what you do for 500 hours maintenance, 2 to 3 years maintenance. So everything has their set plan, what we call PPM, plan preventive maintenance schedule. So ensure you follow according to what is your PPM. Don't feel you are saving money, you are not carrying out. When it will fail you, you may know you want to quit your job. And when you do simple plan preventive maintenance, it will aid you in your job. It will make you to enjoy your work. If all you do is to run around because you fail to do a simple preventive maintenance, they are see you carrying diesel, you are carrying diesel, pouring diesel, drinking diesel, doing all sorts of things for people to feel you are working. No, you are not working. PPM will help you to achieve what you need to achieve in terms of equipment maintenance. Diesel supply, before you and after you take diesel, ensure you know the quantity that you have left and the quantity after delivery. You do plus or minus, you know what was supplied to you. So there are tests that you need to carry out when taking diesel. We have what we call the pH test. We have a gravity test. We have physical tests, and we have a test by odor, the way the diesel smell, how it looks. So there is a standard in the industry that we must maintain. And this table shows what we should tolerate or what we should accept when diesel is delivered to your facility. Most of the tests that we are familiar with, the gravity test, density test, where 0.82 something, 0.86 something. We also do water tests. You use litmus test to do this water test. Your pink litmus will turn to red if there is water content in your diesel. So you also do physical tests. The diesel I like most is the one that looks like purplish in color. So that's the type of diesel that I like most. All right, this is the last phase of this module. We have the grounding system, also known as the earthy system. After all we have said, if the installation or your equipment is not earthed, there will be a calamity. There will be a disaster in your facility. There will be loss of life, loss of equipment, loss of money. So if there is no earthing, it can lead to fire. The building can be set ablaze through lightning, through thunder strike, through earth leakage. So what you need to do after all your installation is to ensure you do a proper earth system and maintain it. Most of us don't maintain our earth. Most of us don't even know where our earth arrangement is in our facility. They don't know. This is why you are in this class. When you go back to your various facility, go and check. Those that are maintaining very large building or very large mall, go and check the number of earthing that you have and where they are serving. So if your earthing system is compromised, that will be the rate at which your ball will be going bad will be high. If your earthing system is compromised, your motor will be going bad, will be getting burnt, because leakage current are supposed to pass through earth to the ground. And if the earthing system is bad, the cost of running your power system, the cost of a utility bill will go up, because that unwanted abnormal current will be circulating around your installation. If the earthing is bad, it's meant to be conducted through the ground. So earthing is something that we cannot underestimate. There's a value of resistance that the earth is supposed to have. It's supposed to be at 0 ohms. 0 is the weakest part of any installation. If the resistance is not getting too high, like I said in our opening class session, if the resistance is high, there will be low voltage. There will be low voltage. There will be no free flow of electricity. Earth is meant to conduct any unusual voltage, abnormal voltage, or abnormal current to the ground. So the value you can tolerate 0.002, maybe 0.2, as the case may be, ohms. The earth is assumed to be 0 potential. Work is not done on the earth. It's assumed to be 0 volts. Anything above that, that means you need servicing. You need to lower the resistance so that there will be 0 potential in that region. So these are the advantages and disadvantages. No, there is no disadvantage about earthing. It only has advantage. It protects the lives of every user of a facility. It ensures the equipment's lifestyle are guaranteed. It prevents fire outbreak in a building. Thunder strike, it conducts that's lightning straight to the earth, because the earth has numerous charges. The thunder will come with positive charge, the earth will pick it up with negative charge and send it to the ground. So the earth must be active. It must be at 0 potential. How do you achieve that 0 potential or 0 ohms? Is by servicing it. What do you use to service it? Most of you are familiar with charcoal, salt. Some are familiar with animal waste. The reason why we use charcoal is to absorb impurity. Charcoal, carbon is an absorbance of impurity. It will absorb impurity from the earth's point. Why the salt is like electricity in water. That is electrolyte. If you do electrolysis, it's electricity in water. It's mixed with water and poured that place. What does that is to increase the conductivity of that place, just like your cable, your copper cable. So it increases the electricity, the conductivity of that point. As long as immediately there is a fault in your installation, the earth conducts it to the ground. We have what we call earth rod. This is the earth rod. This is the wire that is connected from your distribution board. From your neutral is tied to the distribution board, but the metal case. From there, it is connected to the earth. From there to the earth where the rod is buried. This is where you pour charcoal. This is where you pour salt in water. That's an electrolyte. So increase the conductivity, because if you have contact with anything, instead of you being electrocuted, you are protected. The earth conducts the abnormal voltage to the ground. Are we together?
Yes, sir, we are together, sir.
Yes, please.
Okay. Take it as a point of duty to advise organization to always, most people don't pay at organizations, we don't need it. It is your duty to ensure that proper earth service is done. We have biannual, depends on the area you are living in. Because electricity, as I told you, comes with heat. It comes with heat. As this abnormal voltage current is coming, this place where this earth is buried, this rod is buried, is being heated up. It's heated up. Before you know it, it will form, it's like a cake of carbon. That place is dry. It becomes resistive, highly resistive. It does not allow the free flow of electricity, the easy passage of electricity to the ground. What you need to do, you may not need to pull off the electrode, the earth electrode. What you need to lower that thickness, that carbonized area, by putting charcoal. The charcoal absorb the impurity, and the electrolyte, that is the salt in water. It could be sodium chloride, it could be mercury in water, whatever, and pour it in. It will increase the conductivity of that spot. So it allows the passage of abnormal voltage to the ground. Is that okay?
Yes, sir.
All right. So with this, we have come to the end of the module. If there's any question that will benefit every one of us, you are free to ask. And if you have this manual, ensure you go through them and master them, so that you'll be a better facilitating on the terms of electrical maintenance. Any question, please?
Okay, good evening, sir. Hand is up. Please, Oluwashola.
Yes, sir.
Hello,
Please ask our question.
Okay, all right. So please, I want to confirm for 18. So during the course of the lecture, you also mentioned that servicing should be done annually or biannual, depending on the environment. So want to confirm, for annual servicing, which type of environment can we categorize into it? Why for biannual servicing, which type of environment falls into that category? Yeah, thank you.
All right. I'll just answer you. Like I said, I made mention of testing your equipment. So when you carry out tests and you see that the value is going out of range, carry out it might be quarterly. So as worst case scenario, that's why I said annually. So when you carry out tests and you see that the value is going beyond 2 ohms, that's in terms of resistance now. where it's supposed to be at 0 ohms, you plan for service maintenance so that it will not announce to you that, oh, a disaster is about to happen. It is through your test that you determine that, oh, I need to do this thing. Let it be part of your PPM. Include it as part of your PPM. Do you get? Hello? Are you there?
Yes, I'm here. Sorry, I thought mute. Yes, I'm here.
I said, let it be part of your thing. Do your normal test through your technicians and record it. I said, if it's going beyond 2 ohms and above, 2 ohms and above, call for servicing. Thank you.
All right, thank you.
All right. Any other question?
Okay, sir. I think we have a question in the chat box.
Okay.
So Mr. Pochid is asking, how can the earthing system be maintained?
Okay. All right. If you really pay attention to what I just explained, that you have, after carrying out your test, you see that the range is going out of the values are going out of range. You call for it. The thing that you would require, you need a charcoal, you need electrolyte, and sometimes animal waste. I made mention that charcoal absorbs impurity. The reason for maintaining earthing point is to eliminate impurity that will cause resistance to the flow of current, that will oppose the abnormal current that is coming from your installation or your apartment. So nothing should be able to oppose it. So if the resistance is high, the current will be sent back to your installation, to your apartment. It can go and damage very expensive equipment. It can even lead to death. So what you need to do is to ensure you get charcoal, salt in water, sodium chloride or ammonium chloride, the case may be. They call it industrial salt. And lower it where you have this earthing arrangement. So the purity will be absorbed and the conductivity of that point will increase. So that's the process involved. All right.
All right, thank you. Thank you very much, sir. Okay, we have some hands up. Okay. Go ahead, Mr. Absman.
Okay, good evening, sir. Just to quickly, I would like you to still give a brief lesson about the portable appliance testing that you explained briefly. And then lastly, on the check meter, because you mentioned the 2 forms of I think is it energy, something like MD meter, which is maximum demand, and then the check meter. Now, for check meters, my experience with check meters, most times, if I'm correct, they are not prepaid meter, right? Just normal check meter that takes the reading of
Yes.
energy consumption, especially if you manage a multi-tenanted properties. So in that case, I know most times people tend to have a bit of not agreeing with the use of check meter, in reading the energy consumption. So you find that because most times when it comes to the calculation, how you apportion this energy consumption at the end of the day, because sometimes some facility will have both the light from the main supply and the generator, they runs the same on that same check meter. So the check meter takes this reading. Okay, so at the end of the month, you're expected now to take your reading and then do your computation. At the end of the day, you now have to charge it on each of the occupants. So most often than not, you have this tenant coming back to challenge your computation, how did you arrive at some of this? So it's usually a bit of an issue, when you operate using this check meter. So I'd like you to throw more light on that, sir.
All right. Like you said, portable appliance testing.
Yes.
Portable appliances includes this multimeter that can measure various quantity like voltage, resistance, ohms, and so current. So that's possible. What I said, when you are carrying out this, like the 80 we are talking about, we just spoke about, when you carry out this test, record them down. There's a value that the industry permits, like the earth resistance is supposed to be at 0 ohms, 0. So because you are carrying out test, the month, first month you have 0, second month you have 0.1, third month you have 0.8, fourth month you have like 1 ohms. That means it's increasing, right?
Yes.
So when you know that this is the standard and this is where we are to as at the 6th month, and it's going beyond 2 ohms, then you call for maintenance. That's the essence of portable appliances test. For the check meter, if your check meter is correct, if there's no what's it called, obstacle or a problem with the check meter, it should give almost exactly what the maximum value is, the maximum demand is given. The maximum demand take the bulk energy. So each apartment has a check meter that measure how much that apartment is consuming at the end of the month. What you do is initial reading present reading minus initial reading.
Initial reading, yes.
It gives you how much that apartment have consumed for the month.
Yes.
So whatever value you have, you divide it you divide the total amount of energy total cost over the total energy, that's from the maximum demand.
Yes.
Times the individual consumption. Now it will give you the cost of individual apartment, right?
Yeah.
So to give the cost in terms of cost now. So if your technicians are not compromising, you should have the same, because is plus or minus, present minus previous. It will give you what you consume.
Consume for that apartment.
Before you leave any apartment, ensure that the caretaker or the owner of the house sign the reading. It's not something you do in isolation. When you take it, let them sign. When they sign and you have a copy, they have their copy. When you are doing the apportionment, you show it to them. It is clear.
Yes.
There's a formula for it. If you need further clarification on this, Ms. Barakat has my contact. You can reach out to me. Then I'll share more light on that.
That's fine, sir. Thank you very much, sir.
Any question before we call it a day? There's an assessment for you. Make sure you write it and submit to.
Yes, sir. Good evening, sir. I have a question.
All right. Go ahead.
Hello, sir.
Go ahead, please. We can hear you.
Okay, good evening, sir. My question is on generator. You are made to understand that generator comprises of 2 components, the mechanical and the electrical. You know that the mechanical aspect comprises of the piston, which is just to run the electrical aspect, which is the motor, the diode, and the rotor. Now, my question is there anything I can improvise that keep running the electrical aspect apart from generator? Although we've tried to construct something like it before, which due to one reason or the other, it fails. So I want to ask from your experience, is there anything, can you like throw more light to me? Is there anything I can construct that maybe it will only involve just the starting And once it starts, I can improvise either, let me say, solar or battery that will keep running it. Hope you get my
Yeah,
question, sir.
like I said from my explanation, uh, alternator is what you are involved in, what you are considering. That's why we have the wind turbine that does not require fuel. We have the wind turbine as the breeze is blowing. That's fan. The fan is rotating. We have the waterfall. If you go to Shiroro Dam, Kainji Dam, they use waterfall that sets this blade on motion. As long as there is water, it keeps running, it keeps rotating, electricity is generated. What uh, the diesel is doing is to also set on motion that blade. So that's why I said we have various sources of power generation. We have the wind, we have the hydro, which is the water, we have the gas. The gas is coming. It's all what the gas is that is being to a blade, a kind of a shaft. As that air that is coming is hitting the shaft of that alternator, it keeps rotating. So electricity is generated. Battery cannot give you such a alternating current. That's why it is clearly stated that we have DC and AC, direct current, which is from the battery, does not require rotation. You make use of electrolyte. Electrolyte, that's a liquid in electric form. While we have the alternating current that require rotation. So battery cannot give you what generator or the turbine, let me put that way, can give to you. The torchlight battery, you see it does not rotate. Your generator rotates for electricity to be produced at a higher volume. Thank you. All right. I believe we have enjoyed the class.
Please, sir, I think we have some hands up.
Okay, be fast. Let's be fast about it.
Mr. Omopariola Gbenga, have you asked a question?
Okay.
Yes, thank you so much, sir. Concerning the monitoring, consumption of how to monitor our consumption. Like our apartments, the meter they brought to us, MD meter they brought to us before is analog. But most of the time, by the end of the month, like this, before they brought the bill, I already know exactly what's going to come out. In fact, the difference come more than maybe 10 naira. Now, later they change it from the PSCN, they brought the one analog. So that now is a little bit difficult. How can we monitor? Though we do see their reading on the paper, the console reading, and by the time we multiply by the calculation, it's only tally. But now, how can we monitor it the way you explained tonight?
I didn't get you. Analog or digital you have there now?
No, the one we have now is a digital.
Digital.
So it's difficult to calculate, except maybe the PSN stuff.
No, like what most estate is digital. Now, even in my house is digital. What you do, it depends. There is a cycle which they come for the meter reading, right? Maybe every first day of the month or every 5th day of the month. So when they come, you take the reading down. When they come the next time, you take the reading. You now know what you consume, and that is the difference between the last date and the present date is what you consume. You can use your calculator to do that, even your phone. You do the plus or minus, you know how much you have consumed. What you need to know is to know the tariff you are being charged, the band that you are in. Are you in band A or you are in band B? So you use that naira and kobo to multiply your consumption and include your tax, so you know what you consume. Is like I explained, final reading minus initial reading. It will give you your consumption. Times it by the tariff that you are being charged with. So you get your reading. It's very simple. Like I said, if you need further clarification on this, reach out to the admin, the training manager. She can get in touch with me. Just put your question together. We can shed more light on it for your better understanding.
Okay, thank you, sir. I think we have one hand up, Mr. Oluwashola Adeyinka. Can you speak now? Mr. Oluwashola Adeyinka, do you want to proceed with your question now?
Yeah, but I've done that earlier. I was the first person to ask question. I'm fine now.
All right.
Yeah.
Okay.
Thank you,
Thank you very
everyone,
much, sir.
for your time. I appreciate your conduct, and God bless you.
Thank you very much, sir.
Thank you, sir.
Thank you, sir. God bless you.
Thank you, sir.